In this video we are going to look at what happens during an experiment. Both IconNMR and TopSpin will show activity and display progress of the run. I will give a short description of each of these steps, and we will also look at the operation of the sample changer. When you enter an experiment and click on the Submit button, Icon will first show a yellow light on the status column. If there is no current sample running, this icon will quickly turn green. This indicates that the experiment is now active. A corresponding line will also now show in the preceding experiment table. The status icons at the top right of IconNMR will show, Go to Sample, and a flashing green box will be on the icon that looks like a traffic signal. This status indicates that the sample changer is inserting the sample into the magnet. Let's watch the changer in action. The first sign of activity is the status light on the sample changer will flash yellow. The changer will then rotate the carousel so that the active holder is under the column. The status light will start flashing green and yellow. The tube that holds the sample is raised to form an airtight seal at the base of the vertical column. Then, nitrogen gas is used to levitate the sample to the shuttle at the top of the column. The shuttle, with the sample in place, is then moved over to the top of the magnet bore. The sample is then released down the bore and nitrogen gas is used to slow down the descent. The spinner will fall into the spinner stator that is above the probe and the sample tube will extend into the probe's coil. The system gives the sample a quick spin to make sure it is in the correct position. When the system detects that the sample is fully inserted, the changer status light will stop flashing and turn solid yellow. Note that the tube that raised the sample to the base of the vertical column will remain up until the sample is returned to the carousel after the run. Both the raised tube and the solid yellow status light indicate a sample is in the magnet. There will now be a check in the load column of the preceding experiments table in IconNMR. The top status icons will move from the Go to Sample status to show ATM running. This is the probe tuning step that occurs for most experiments. The traffic light will still have a green flashing box. Tuning optimizes the probe to give the best radio frequency performance and gives the system the best sensitivity. This step usually takes about half a minute. After the tuning is done, there will be a check mark in the preceding experiment table. The status icons on top will now show a solid green box around the traffic light icon and the system will move on to the locking step. Field frequency locking uses the deuterium NMR signal of the solvent to compensate for any magnetic field drift during the experiment. It assures that the frequency of signals coming from the sample stay constant and add up to single sharp peaks after collecting multiple scans. After this step is complete, the preceding experiment table will indicate this with a check mark and the top status icons will move to the shimming step. Shimming is an optimization of the magnetic field uniformity. This allows for the best peak line widths and a more resolved spectrum. For most solvents, the system uses the deuterium signal from the solvent to perform a technique that is similar to a magnetic resonance imaging experiment. A series of correction fields are adjusted to give the most uniform field across the length of the sample. This step will take a longer time for samples that are not properly prepared. A check mark will show under the shim column when this step is successfully performed. The top status icons will move onto the auto receiver gain adjustment step and then to ZG in progress. The system is now collecting the NMR data for the selected experiment. The status icons and preceding experiment table will both show when the acquisition is finished. The processing step is quite short and will show in both locations when done. Icon will then move onto the next experiment in the queue. Now let's see what these same steps look like in TopSpin. All of the activity will occur on the lower section of the program called the Acquisition Status Panel. This panel is broken into sub-sections and each will give you information about the system. The sections to the right are less useful to monitor during the course of a run and we will focus our attention on the left side of the panel. When the sample changer is active, the symbol in the sample section of the panel will show a question mark. When the sample is fully inserted, the system will change this image to a sample with red bars across the tube. At the far left of the panel you will see a string of text that indicates which operation is being performed. This will show the basic commands that TopSpin is running and they can be fairly cryptic. The ATMA started and in progress lines are the beginning of the probe tuning step. There will be a few preliminary steps before the tuning operation actually starts. The acquisition information sub-panel will become active during the tuning optimization. Next to be performed is field frequency locking. Again, there are several steps during this operation and the text string will be quite active. Note that the lock section in the panel will initially show a low number that indicates the sample is not locked. When the operation is successful, the level will increase and be set to around 60%. The shimming step is performed by a command called TopShim. Again, there are several preliminary operations before TopShim is fully active. During this step the system will collect data on the deuterium channel of the probe. The acquisition information panel will show activity as data is collected. The FID flash section will show an icon that indicates data is being acquired. The flashing rate is not in sync with the actual data collection and it is just a small indicator that the system is acquiring data. Note that the lock level drops during the shimming process. The system uses the same channel on the probe to perform both locking and shimming. Therefore, it has to temporarily turn the lock off during the shimming. It will relock the sample once the shimming step is complete. Next, the system will optimize the receiver gain and start the NMR experiment. During the run, the acquisition information section will give you the progress of the data collection. The number of scans will update as each is collected. If you desire, you can double-click the acquisition information section to load into TopSpin the currently running dataset. You could then transfer the running data with the TR command so you can manually process the data before it is completely collected. We will discuss these processing commands in later videos. Checking on the experiment's progress is useful for long experiments and you can determine if the current number of scans is sufficient and the experiment can be halted before the full number of scans are completed. Once the experiment is completed, watch TopSpin process the data to give you a spectrum that is referenced, integrated and displaying peak frequency labels. We will discuss the options for further data processing in later videos. The sample will be ejected from the magnet and returned into the sample changer's carousel. The process is the reverse of the sample insertion. This concludes this video on what happens when the system runs an experiment. We would be happy to discuss with you more details about the system and the steps it performs to collect data. Please see the staff if you have any questions. Thanks for watching.